Hi guys, welcome back to another video of me teaching, and today I have this problem on the board for you guys. So why don't we just get into the question? Well, this question is actually a bit chill, so you guys can just relax. Okay, so what should we do here? Well, why don't we first try? When n is equal to 1, of course this is true, so for all the working out below, n is going to be greater than 1. Now, the first thing that we might notice is maybe we can use the AMGM formula. So, we know that this thing will just be greater than 2 times the square root of those two multiplied together, which is the nth root of 21, right? And now, you can actually think this of 21 to the 1 over n to the power of 1 over 2. And we can actually just swap those powers around and everything will still be the same. So that means that we can just change this into, we can swap the nth root to the outside and the square root to be in the inside. So 2 times the nth root of the square root of 21. You see, we just swapped it out. So we want the square root to be a numerical value, right? Well, what should it be? Well, can't we just change 21 into 84 out of 4? Now, I did this because 4 is a square number, but 84 isn't. But 84 is very close to a square number, 81. So, if we change 84 to 81, then we know that it must be greater than 2 times the nth root of the square root of 81 out of 4, right? So this is just equal to 2 times the nth root of, this is just 9 out of 2, which is just 4.5. So now we have to prove that this is greater than that. Now, what do we do now? I can actually split up 2 of these into one of them plus the other one. So I can do that by, first I'm going to move this nth root of 4 to this side and one of these to that side. So we have to prove that the nth root of 4.5 minus the nth root of 4, is this greater than? So we move one of them here, the nth root of 5 minus the nth root of 4.5. So right now, I'm actually going to create a function and you understand why. So my function is going to be the nth root of x plus d minus the nth root of x. Look, both of these sides follow this function. And in our case, d is just equal to 0.5. So we can see the left-hand side is just f of 4. And similarly, the right-hand side is just f of 4.5. So we have to prove that f of 4 is greater than f of 4.5. Now, if this is true, what does this mean to the function? Well, this means that the function must be decreasing. And how do we figure out if a function is decreasing? We take the derivative and see if it is less than 0. So we take the derivative of f of x. F prime of x is equal to, we can use the power rule, becomes 1 over n times x plus d to the power of 1 minus n over n. Then we subtract 1 over n x to the 1 minus n over n. And this 1 minus n over n is just 1 over n minus 1. Now, I can factor out a 1 over n. So the inside would just be x plus d to the power of 1 minus n over n minus x to the 1 minus n over n. Okay, so we know that x and d are both positive and n is greater than 1. So we can conclude that these powers are actually negative and the base are positive. And since d is positive, then we know that x plus d must be greater than x. So with all this evidence, we can see that this whole thing has to be less than 0. So we know that f of x must be decreasing. So we know that f of 4 is greater than f of 4.5, so we proved the whole question. And don't forget, when you prove the question, don't forget to write the little box. Okay, so this is the final answer of this kind of relaxing question. So thank you guys so much for watching, and if you enjoy my video and you want more videos like this, please consider liking and subscribing. If you want to master something, teach it.